in textile, aerospace, and advanced manufacturing sectors. This afternoon, we will host Professor Gualtiero Fantoni from the University of Pisa, and he will give us some insights about the digital transition of SMEs, in particular, some opportunities and some insights in textile and clothing sector. Before giving the floor to Professor Fantoni, I would like to share with you some information about GALACTICA project and the opportunities that are open at the moment. So I will share my screen with you in order to present a few slides. Okay, I hope you can see my screen.
Yes.
Perfect. So, as I said, this is the 8th webinar of GALACTICA. It is about advanced manufacturing technologies for improving textile product environmental and social sustainability, digital transformation, not only through technologies. So, GALACTICA is a project, is a partnership that is based mainly on 3 sectors, which are textile, aerospace and aeronautics, and advanced manufacturing. So we can say that in the beginning, these 3 sectors were separate. What we want to do is to make them closer and to exploit digital and advanced manufacturing technologies and cooperation opportunities that are possible among SMEs, small medium enterprises of these three different sectors. So we aim at a new overlapping of these value chains, at the digitalization of these industries, and the flourishing of cross-sectoral collaborations. In particular, of course, we address SMEs from the textile and clothing sectors, so technical textile, fashion, and home textiles, and the SMEs from aeronautics and aerospace. And as an horizontal component, we have the advanced manufacturing sector. So the collaboration is among 2 of these 3 different sectors. GALACTICA is a partnership composed by textile clusters, in particular AEI Textile, which is the cluster of technical textile of Catalonia, that is the coordinator of GALACTICA. Next Technology Tecnotessile, which is the organization from which I belong and is managing the Tuscany Fashion Cluster. ATEVAL is the cluster of home textile in Valencia, in Spain. Then we have the aerospace clusters, Coralia in Greece, Suderelbe AG in Germany, and CTA in Spain. We have the advanced manufacturing partners, Produtec in Portugal and the EMC2 in France. We have the investors with IBAN, which is the association at European level of business angels. And we have the startup ecosystem with Science Park Graz, based in Austria. Here you have the list of the webinars organized by the GALACTICA team. Now we are at the 8th one today. Then we have 2 other webinars left. One will be on the 26th and the last one will be on the 30th of April. So you still have time to join for these remaining 2. What I would like to underline is that at the moment, GALACTICA is the first call for proposal open. So any SMEs belonging to one of these 3 sectors can join and submit a project proposal. There are 2 different proposals typologies. The first one is the Pioneer Acceleration Program. This is a call that was designed for SMEs in particular to explore new cross-sectoral value chain feasibility for developing a minimum viable product connecting two or more of the sectors. So aerospace, textile, and advanced manufacturing. So here is the idea development until the realization of the first prototype, which is the minimum viable product. Only one SME is eligible, but also partnership of different SMEs are eligible, and the funding, the voucher for the SMEs is up to 20,000 euros as a lump sum. So the KPIs are building the prototype in the form of the minimum viable product, testing the business measurement and the user validation tests that will provide critical information for learning about the hypothesis validity, adjusting the product service with a dedicated learning process. The duration foreseen for these projects is 4 months, and 20 projects will be funded under this first call. The deadline for submitting the proposal is the 19th of May. The second typology is the Orbital Projects. This call will provide 1.2 million euros in direct funding. Here, the applicant has to be a consortium of at minimum 2 SMEs from 2 different sectors, from the European Union and UK. Funding is up to 58K for SME, up to 100K per project as a lump sum again. And here we have a higher TRL, so we are aiming at the implementation of functional prototypes and demonstrators for new cross-sector value chains connecting 2 or more of the sectors, aerospace, textile, and advanced manufacturing, while funding the integration of non-technological innovation for spinning up the market match. The activities is experimentation, technological maturation, prototype system integration, standardization, and the duration is 6 months. Here, under the Orbital Projects, 8 projects will be funded in the first call, and again, the deadline is the 19th of May. Now, before giving the floor to Professor Gualtiero Fantoni, I want to introduce him, but I need a couple of minutes. Okay. Let me introduce Professor Fantoni. He is associate professor at the University of Pisa, founder of Fab Lab Pisa and 4 university spin-off. Main engineering in mechanical engineering at the University of Pisa in 1999, PhD in robotics, automation and bioengineering from the University of Pisa. His research interests are in industrial grasping, handling, feeding, and in creativity, crowdsourcing, and collaborative design tools. He has wide experience in automatic analysis and technology foresight, and is expert of technologies enabling the director of the Master of the University Industry 4.0 Design. His publications include more than 50 peer-reviewed papers. He's co-inventor of more than 10 patents. He has managed several projects as coordinator and currently scientific coordinator of Sprint 4.0, Assets Plus, and the new E10 projects. Now, before giving the floor to Professor Fantoni, I would like to ask all participants to drop their questions into the chat, and they will be addressed by the speaker at the end of his presentation, which will last more or less 25-30 minutes. Now, thank you very much for being with us again, and the floor is goes to Professor Fantoni. Thank you.
Thank you, Enrico. I'm going sharing. Yeah, it doesn't work properly. Okay. Good afternoon, ladies and gentlemen. It is really a pleasure to be here, hosted by GALACTICA project. I would like to thank Enrico for this invitation. My presentation is a sort of provocation in order to let you think about. So don't trust on me, but try to follow the demonstration. So the idea is to show you how to transform the industry into a smart industry. Not thinking only about technologies, but thinking around. So the outline is the following. I hear some noise. I start with an introduction, then what are the assets in the new digital era. Later on, we will discuss about a smart factory or a smart enterprise. And at the end, I wrap up with conclusion. Actually, I would like to say the outline in a different way. So a twin outline. First of all, I'll introduce the master of the future or the supposed master of the future. Then the technologies, the enabling technologies for Industry 4.0, with the question, are they flat or they have an order? Then we will discuss about what are the new assets in the digital area. And with, for example, I try to demonstrate that we have to go beyond what the mainstream is saying. With some drawbacks or with some point of attention, for example, the Einstein paradox applied to the digital twin. I'll try to argument the evolution between data-driven companies or analysis agent company, probably a new model. Finally, with a discussion, short discussion about exponential organization. So, master of the future. If we have a look at the capitalization of the major technology platform, 7 out of 10 in 2018 were digital. So you can see here Microsoft, Amazon, Apple, Alphabet, Facebook, SAP, Tencent, Alibaba, and Samsung. They were really big in 2018, but the COVID started destroying or accelerating the growth of some of them. For example, Amazon increased their number of employees by 100,000 in a week during the first period of the first wave of COVID. And some unicorns, so-called unicorns, demonstrated to be more a donkey instead of real unicorns. So Booking, WeWork, Airbnb, and Uber suffered from the first COVID and later COVID waves. If we have a look at the capitalization now, we can see that the first automotive company is Tesla. But Tesla actually is a computer on wheels. If we have a look, the first chip producer is TSMC. If we see the first bank, we have JP Morgan. The second chip producer is Intel. But as you can see, their value, their stock market is uncomparable with respect to Apple, Microsoft, and so on. The first pharmaceutical is Roche, and you can see the value is very, very low. The really first automotive is coming after the 30 position. And if we put together JP Morgan, the biggest bank, and Novartis, that is a very famous player, their values is something like 1/3 of Apple. Is it possible? Is it possible that all the value, despite of the real asset that JP Morgan, the number of people, the number of patents Novartis have, is so different? Maybe that the levers, the digital levers, will be democratized in future, and the capitalization could have some shakes in the future. So is it a matter only of time perspective? Maybe a standard company, when all the assets will be digitalized, will have the same value of a naturally born digital company like the first 6. Yeah, my presentation is on this line. So the mainstream during the last year was saying that we are in the middle of the 4th revolution. There are technology to buy in order to become digital and to exploit the levers. But it is not true, in my opinion. Let's see. the origin of Industry 4.0, that is in a slide in Italian, is that this is the fourth industrial revolution. It is true. In my opinion, it is not. And the reason is that we are missing a really key revolution that is in the middle between the third and the fourth. And the revolution is internet. Internet for people, but internet also for industry. And the fourth industrial revolution without internet could never happen. But the mainstream, the marketing of the big corporations said that there are technologies that are super important for becoming digital. And as you can see here, the Italian version of the enabling technologies, we saw them all at the same level. Advanced manufacturing solutions like cobots or robots, additive manufacturing, at the same level as cloud, cybersecurity, and big data analytics. But are they the same? And why we are missing quantum computing and artificial intelligence? Why not adding other sector-specific technology like nano smart material, for example, for your industry, or C4I for aerospace and defense? So it is a problem also of grain, not only of level, but how these technology are disassembled. And presenting like that is like going to the supermarket and buying for becoming digital. But first you have to become digital, then you have to buy. Probably another version that is more true could be the following. We must have the automation and 3.0 at the baseline. Then we have to build our basement on concrete pillars. So like horizontal and vertical integration, how to migrate information within the company and within the supply chain. Then industrial internet, how to get the data out of the machine, out of the interaction between different players, and cybersecurity. Because if you have a breach, wasting your value is matter of just a second. And the future of industrial fight will be probably driven by cybersecurity or cyber offense. The other enabling technology probably are content dependent, while other technology like artificial intelligence are totally cross-cutting. But we have to build on real strong fundament, and then adding the other, maybe in future specific technology you can leverage on. The other aspect we have been exposed, the other buzzword that has been so pushed by the number of players behind the fourth industrial revolution are the asset and how to digitalize them. So how to create a digital twin for the real asset you have in your industry. Digital twin is easy to say, but difficult to do. Because if we have a roller like the one you can see here, for the research and development, it is a matter of drawing. For the one that is preparing the entire plant, it's a matter of its dimension and how it moves inside the simulation before building the entire structure. For one interested in manufacturing, the problem is the material, how it is manufactured, how the turning affect the interaction with the material. And for the guys and girls in logistics, the problem is the spaghetti chart or the time and place where to pick and release the object. But for sure, it is easy to pick an object, whatever it is, a boat, a fridge, a company, a greenhouse, and digitalize it. But the problem is that if data are the new oil, sometimes you are thirsty, so you don't need oil, but you need water. So having data does not make you able to trust or to extract information that data are not containing. And you cannot predict information that data do not contain. So you cannot see beyond the information you have. You cannot see beyond the data. So the information about production probably are not useful for you if you want to determine the failure of a motor. But the information about the prodromic element of a motor failure, like noise, temperature, and so on, are not useful for calculating the OEE. So data are for sure important, but the hypothesis behind what you want to see is even more important. And all the information in the international standard, the reference architecture model in the DIN spec 91345 is about the asset, how to transform the asset. And without having read this fundamental document that is costless because now it is for free, people have all the opinions about digital transformation. And the standard is a superb piece of art in terms of engineering school. And figure number 2 is saying that every asset should be digitalized. And the examples are very crazy. They are not discussing about digitalizing a machine. They are discussing about digitalizing a USB stick, the brain of a person, or a paper, not a machine, not a transpallet. So the standard is pushing our ambition toward a new level. Which kind of example we can think about? Well, we can have a look at our balance sheet and try to understand what are the assets we are putting in the balance sheet. Or we can use, for example, the 4M method. We can see that machines, material that are quite easy to twin or to digitalize, but also methods, milieu, so the environment. We must digitalize stationary and mobile object, tangible, easy, and intangible, difficult object. Easy and difficult component or asset, internal parts or internal document, and external information. So everything should be digitalized. But moreover, we can think about just the smart factory, the one in the cloud, in the gray cloud on the right. But there are also other pieces that are very close to Industry 4.0 as philosophy. We can have smart home or smart building. We have e-health, smart mobility, and smart grid. Let's take the attention on the first one, number 1, 2, 3, but you can extend also to smart mobility. The idea is that looking inside is fundamental, but also looking outside can help you in transforming in the proper way and becoming as digital as the master of the future. So if we think about a smart building, information that could be useful, we have to learn from the one that are producing building houses and stuff like that. And thinking that compressed air, fire extinguisher, defibrillators, PPE, water, cleaning, maintenance, and so on, all these services should be transformed into their digital twin and integrated in the manufacturing execution system, because they are bricks necessary to really understand how your company is behaving. E-health in mess. Well, man down is a problem. The fact that people are or not wearing PPEs, the fact that people have or not the certification and qualification to do a particular operation on some very critical object, or the COVID-19 new needs like social distancing and disinfection, could be elements that are more closer to e-health than to standard factory. But we can use them in order to help people in understanding if a COVID contact was happening the day before. If someone is going in an area that is too crowded and this area needs disinfection, for example, or conversely, thinking about a scenario in a company, if someone is accessing an area where he or she has not the right to go. So also this element coming from the the e-health work can be used in a company. Smart grid in mass. Okay, in general, if we have a look at this paper, we can see that the consumption of machine tools is often unknown, that sometimes it reaches up to 20% of machine consumption, and sometimes it is even more. The standby consumption takes something like more than 20% of the full operational power consumption. And the poor connection between the energy management and the MES is preventing us to implement manufacturing policies based on consumption, and also to trade some energy for different costs in different part of the day. So adjusting our production according to the cost of energy. If we think in a more open way, probably thinking about smart grid and integrating this information in our MES is fundamental. And the last but not least, I'm not a fan of the last dream or nightmare of computer integrated manufacturing, where people were designing a factory with the lights off because no people there. Okay, I'm a fan of people in the company because we need eyes and brain there. So it is important to map their skill and abilities, and that's quite easy. But their task and activity, quite difficult because of also GDPR. And also extracting knowledge is feasible, but the know-how is very difficult to grasp. So there are elements fundamental for our evolution, also in the digital way, to be gathered, to be captured and transformed into value. So for sure, it is not difficult with something like a bracelet, a contactless bracelet, Bluetooth or Wi-Fi, to understand if someone is picking an object, releasing, assembling, and so on. So it is quite easy without disturbing the person to do the time measurement method strategy to understand what are the distribution, as we did in this case with this example. But how to capture their brain, how to capture the ability to solve the problem. Probably by using what they say, probably by using the document they write, in order to detect not only their knowledge and skills, but also extract the know-how and making it available for the other that maybe don't have this kind of know-how that could grow in time. For example, if we take as an example a patent, and we try to capture the information, the standard way is capturing metadata, abstract description, figures, and claims. No more than that. But if we don't tag in the proper way the document, probably it is a full text, difficult to read. If we split the description, for example, in problem to be solved, and we tag, actually we highlight with a particular color of our highlighter, then the solution of the problem, and we can create a couple. We can see the background of the art and how different people solve the problem. We can extract the bill of material. We can, for example, in the chart, in the figure on the left, we can highlight the different part just by scrolling with the mouse and going in the exact part of the text where the part is described. But also understanding function, behavior, structure, physical effect, and having annotated figures could reduce the time you spent in analyzing a patent or in comparing different patents. So capturing means designing first. Same paradox. If you are able to do that, never mind that the twin is not the exact replication. So the digital twin is not the exact replication of the real product. We should maintain them synchronous by communicating each other. Otherwise, we incur in the Einstein paradox of having the two twins that in time, because one is going in a space shuttle, the time change for the two. And we have to assure that digitalization, so how we think about the product and their connection, is kept by the communication, even they are different. And think also in terms of physical evolution of the two twins. And we have to make them speak in order to let them to continuously connect and to remain the same age, same information. So the real and the digital. If we are able to do that, we are able to keep under control and updated all the information that we need for deciding. Okay, actually, you understood that my goal is going from data-driven to analysis ager, because my goal is transforming the information into actions. But let's see. That's the standard ACATEC approach for 4.0. And if you can see, after the precondition on the left, the ACATEC scale is saying that a data-driven company first is trying to understand what is happening, then the reason why it is happening, then when new things will happen, and at the end being able to transform the information about something that will happen in the future. My approach is completely different. I suggest to transform the Six Sigma methodology. It is very famous, the MIC approach: design, analyze, design, measure, analyze, improve, and control, into a new version. So define first, then analyze. We have to formulate hypotheses. We have to design the analytics. We have to design the analysis before starting measuring. And the reason why is that we have to think about the information we need for taking the right decisions. We have to formulate a hypothesis without asking the data for providing us with insight. We have to be aggressive with respect to the data and formulate a hypothesis and use the data to demonstrate or confute our hypothesis. Then measure and analyze in order to have insight or to have demonstration or confutation of our first hypothesis. And then integrate and change. Integrate in order to have all the data together and all the information together to be accessible to the right people, the ones that are going to decide, and change, because this process is quite challenging, and the first change is not in the digital process, but in our brain. So thinking digital is the very challenge of this period. So for me, big hypothesis win over big data, and keeping the man in the middle is the only chance to create in a creative way new hypotheses. Actually, in my opinion, the models have to be built by a human being, not inferred from the data. We are wasting time, we are wasting knowledge. And also, we should go for what we need, what we want to extract, and what to analyze with respect to what you have. What you have is just what you have. What you want to see is the future. And also, the useful data are the ones that help you in understanding, in taking good decisions, and also the one that let you to put the right person in the middle for letting him or her thinking. So conclusion, Industry 4.0, in my opinion, is the extreme consequence of servitization and softwarization of our physical world. And it is the natural consequence and the goal, because everyone tried to maximize scalability and reduce the cost in order to increase the margin. And the trick now is using microservices after digitalization. Every asset must be represented in a virtual world. And in my opinion, no matter if they are real twins or only digital shadow, I prefer digital shadow with a purpose with respect to super digital twin without any purpose or any guess. And the idea is that each digital asset must be accessible and actionable. from the information world, so everyone that needs an information and has the power have access to. So my last slide to conclude is my personal contribution. So I invite you to read this book. It is quite old, actually, published in 2015. It is about designing exponential organization. But if you read this book after the marketing about the Industrial Revolution, whatever we saw in our industry that are changing with every advantage and also with drawback, you can see that many of the elements connected to the scalability of the big corporation we saw, the master of the futures, are very close to the one we discussed before. So if we are able to create a very fast experiment, hypothesis on the data, if we are able to simulate hypothesis on the data, if we are able to create dashboard interfaces, algorithm, we can leverage some asset, also physical asset. We are able to create communities and extracting information about our and other community. Probably we are transforming our organization into a digital, exponential, or non-linear organization. And that's probably the challenge we have now. So thank you very much. I'm here for your questions.
Thank you very much, Gualtiero, for this very, I would say, concrete and very also up-to-date presentation regarding this difficult world where we are trying to move, which is the world of digital, which is, as you showed us, like a parallel world that is moving beside us in everyday routine of our SMEs. Let me invite once again the participants to drop their questions in the chat. I don't see many questions so far, so I will start with a very maybe naive and simple question, but of course we understand the importance of keeping everything under control and the importance of digitalizing every single aspect of a living entity, like it can be a society, a company, or a manufacturing process, which is made of tangible and non-tangible assets. So it is very, very hard, I guess, for one SME. I'm thinking on behalf of textile SMEs that are very primitive in this respect, no, because they don't have sophisticated Internet of Things systems or analysis of data or big data elaboration and stuff like this, especially as regards their internal manufacturing process, but it can be applied the same consideration to the market or to the sales that they do. No, it is very hard for them because they are very down to earth, they are very practical, and they are very much used to deal with manufacturing problems. So what is the product that I'm going to produce? How can I adjust the production defects? How can I satisfy better my customer? And they don't see the digital side of all these questions because they just see the practical side of them. So if I am a fabric producer and the color of my fabric is not so good, that it's not in line with what was the sample requested by my customer, I will dye it again, I will repeat the dyeing, I will try to adjust, and once this practical exercise is done, they give the product to the customer. And they don't understand that maybe having a digital twins could help them a lot with respect to the improvement of the manufacturing performances, because maybe that problem won't be repeated again, but they really don't know where to start. So what is the practical advice that you can give to an SME, to a small medium enterprise, which is not used to adopt such sophisticated methods for their daily production?
The problem is well known, and you are aware of it because you are playing actually in a quite difficult ecosystem. I think that we can start from paper and pencil with our SMEs. So helping them with, for example, lean manufacturing to understand where wastes are. Starting from waste, optimizing in some way or adjusting the processes is the first step. Because digitalizing the waste is not true at all. If we start with a very small project in the core, if they like the product, that's the reason why they are successful in the market. Probably it is the best place to start off. If they like production, we can start from production with a very small project. And I think that your Galactica project is moving towards this direction. With the small proof of concept is really the trick. But you know that in this parallel world, if you are digitalized, the speed is the light speed. So the companies that will embrace first the digital transformation probably will have an advantage in the future. So helping the ecosystems in Europe to transform themselves is the real value we can add to our ecosystem. So small project, and then migrate from a single machine to another one, to the closest one. In my opinion, very important is to try to explain the CEO the return on investment and demonstrate with calculation, simple calculation, what will be the return of investment or the payback time of such a digital transformation. And having a small support and helping them in understanding probably is the key. This revolution is not a technological revolution, it's a mindset revolution. And you said something similar during your question, because the system, the ecosystem is probably too close to the product, but there's value there. And probably they are more familiar with the technical issue with respect to the digital one. So we have to follow their aspiration and their ambition, but also try to move their approach towards the digital.
Thank you very much, Gualtiero. That's what we try to do in our everyday, activity with the SMEs, especially as far as clusters are concerned. But it's not always very easy, also because, as you said, we have to show them something. So you have to show them what is the return of the investment, what is the payback time, what is the concrete benefit that they can get out of it, and the fact that we are talking about something non-tangible, because digital solutions are intangible. It doesn't help. Doesn't help because the manufacturing in the companies, the entrepreneurs in the traditional manufacturing, like could be textile for fashion and clothing, are quite reluctant, especially in terms of changing their mindset. So I guess that an initial stage in which a big and I would say very invasive program in terms of training, education, information, informatic campaigns. This is something with which you need to bomb your target group, because companies otherwise do not understand or do not realize what is the value behind it. And this is the main problem. And what do you think about the set of incentives, like in terms of public funding, that are now available more or less in every country or in every region of Europe to support this digital transition? Do you think they are sufficient? Do you think that they can really support this moving forward of the small medium enterprises, or do you think there is something missing with respect to these incentives?
Well, I think, as you said, the importance of training is key, is the key. So there are a lot of programs and also money on the next year on training, upskilling mainly, and reskilling of the employees. Textile is not yet in the Pact for Skill, while automotive, aerospace, and defense. So in some way, as you said at the beginning, textile is close, okay? I think so that you can, your companies, the company you are targeting, can have also this opportunity. We have not to waste the money. So when you select the company, probably selecting the project is okay, but selecting the ones that can become the ambassadors of what you did together, of the digital transformation, is even better. Because, you know, I spend time with you in Prato area. Sometimes you have some champions, really smart entrepreneur, but they don't like to say anything about what they do in their company. So doing an amazing project with them has almost zero value for the ecosystem, because they don't want to become the lighthouse for Prato. They want to keep everything secret. So also in this case, if we have 4 or 5 key opinion leaders in each area with a very good small project about digital transformation, maybe logistics, maybe some machines, that would like to tell the other that is possible, probably the example makes more than our daily effort. Because me and you, Costanza, and all the other are knocking at their door, but they are trusting us. I don't know. Probably they prefer to have an example next door that did a project, and they can interact a little bit and understand that that's the true way for transforming. You're on mute.
No, sorry, I was saying that you are absolutely true. The word to mouth is still working a lot in this environment, so they may be better copy what the next door company is doing rather than investing their time and their little resources into experimenting something new or something different coming from an outer an outer player, like could be a university or a research center and these kind of things. So it's really true. Since I don't see any more questions in the chat, I think it is time to close this webinar. But before closing, I would like to thank once again all the participants for being with us today. I hope you have found this presentation as interesting as I found it, and I would like also to, of course, thank for being with us Gualtiero for his very enlightening presentation. Thank you very much. I would like to remind you once again the next webinars of Galactica, which will be on the 26th of April at 4 p.m. CET and the 30th of April at 11 a.m. CET. And once again, if you have a nice and digitally inspired, I would say, project idea, you can of course, apply to the open call of Galactica by entering into Galactica website, which is galacticaproject.eu. From my side, it was really a pleasure to stay with you today, even if virtually and not physically. And thanks once again, Gualtiero, for his presentation, and hope to see you soon on the next coming Galactica events. Thank you very much, and good afternoon. Bye-bye.